So the problem we have here is to use the definition of a derivative to find f prime of x provided that f of x is equal to x squared plus 1 divided by x plus 3. So the definition of a derivative is the limit as h approaches 0 of f of x plus h minus f of x divided by h. Okay, so in this case, our f of x is this function over here. So we can say that our limit is really equal to x plus h squared plus 1 divided by x plus h plus 3 and minus f of x, right? F of x is here, so we have x squared plus 1 over x plus 3 and all of that divided by h, and we're taking the limit as h approaches 0 of this term over here. So if we find the common denominator between these two fractions, then let's work on the numerator first. We have that the numerator becomes x plus 3 times x squared plus 2xh plus h squared plus 1, and that's going to be minus x plus h plus 3 times x squared plus 1, and all of that is going to be divided by x plus h. So x plus h plus 3 times x plus 3 times h, and we're taking the limit as h approaches 0 of this. So this is going to take a bit of time to distribute, so let's take it step by step. We can distribute the x into this whole term, and that's going to give us x multiplied by x squared plus 2xh plus h squared, and then plus 1, and then 3 times this whole term here, so that's going to be a plus 3 times x squared plus 2xh plus h squared plus 1. And then we have this term distributed into the x squared plus 1. So that's going to be minus, let's see, x squared times x plus h plus 3. And then just a regular minus x plus h plus 3, since it's just a 1 over here. So we have minus x plus h plus 3. And let's go ahead and simplify this a little bit more. So this becomes x cubed plus 2x squared h plus x times h squared plus x, and then we have a plus 3x squared plus 6xh, and then over here we have plus 3h squared and then a plus 3, and then we have a minus x cubed minus x squared h minus 3x squared, and then over here we have a minus x minus h and a minus 3. So we notice that the x cubed cancels out with the minus x cubed over here. We have a minus 3 that cancels out with a positive 3 over here. We have a 3x squared that cancels out with a minus 3x squared over here. Also, we have a xh squared. Oh no, actually that one doesn't cancel out. This is a x squared h, that's a xh squared. So our remaining terms are just going to be 2x squared times h plus xh squared plus x, and then we have plus 6x times h and a plus 3h squared here, and we have a minus x squared times h, a minus x and a minus h, so minus x and a minus h. And let's see, can we combine any more terms? Let's see here, 3h squared, 2x squared h. Yes, we have a 2x squared h over here, and we have a minus x squared h over here. So that becomes just a regular x squared h. So let's see here. we get a regular x squared times h, and then we have a plus xh squared. Oh, and the positive x and the minus x cancel out over here. So x squared h plus xh squared, and then a plus 6xh, and then we have a plus 3h squared here, and we have a minus x squared h. Oh, I'm sorry, we already combined that already, so we neglect that. Let me erase this. Right? Because we combined this term over here with this term over here. So we just have this, 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 and a combination of this and this. Okay, so what we have is x squared times h plus x times h squared plus 6x times h plus 3h squared, and all of that is going to be divided by x plus h plus 3 multiplied by x plus 3 times h. And then since we have one h in the denominator, that cancels out with one h in the numerator. This just becomes x squared plus x times h plus 6x plus 3h. Oh, that's just 3h over here. And all of that is going to be divided by x plus h plus 3 times x plus 3. And we're going to take the limit as h approaches 0 of this function over here. So as h approaches 0, we have this term becomes 0, this becomes 0, and the h in the denominator over here becomes 0. So we have our limit is going to be x squared plus 6x divided by x plus 3 squared. And this is our answer for the problem.